Welcome to page 2 of your probability packet. You are on lesson 1.2, and we're going to get some extra practice with the probability scale. A single event is one event or action that occurs, like rolling a number cube or spinning a spinner once. Let's take a look at the situation we've been given. A number cube has been rolled once. Express each probability as a fraction, as a decimal, and as a percent. Well, let's take a look at our scale again. We know our probability scale starts down here at 0. And any event that has a 0 probability is impossible. And on the other end, the scale has a probability that measures 1, which means an event is certain. If we're in the middle of the probability scale, our event has a 50-50 chance or an even chance. We know as we get closer to 0, our chances become less likely. The chances grow weaker and weaker as you approach 0. And events down here at this end of the scale are highly unlikely. And in the other direction, the closer we get to 1, the stronger our chances are. Those are highly likely events that have a probability near the number 1. And we know that probability can be expressed as a fraction. And in fact, anytime you think of probability, you should immediately think of a fraction, which can then be divided and converted to a decimal, and finally converted to a percentage. So percentages make it very easy to compare probabilities. For the following probabilities that we're going to calculate, we're going to use a number cube. Now, our pool of elements or our possible outcomes for a number cube are as follows. Please draw this little pool and think about what we could roll. We could roll a 1, a 2, a 3, a 4, a 5, or a 6. Each outcome is equally likely. A 1 will show up supposedly just as many times as a 6 would. Each of them have an equally likely chance of showing up. So, we're going to calculate a few probabilities using this pool of elements. Let's use the room below in order to calculate a few simple probabilities. Once again, under the number cube, I'm going to list the possible outcomes. This is called your pool of elements. Please draw this along with me. You could roll a 1, 2, 3, 4, 5, or 6. 6 equally likely possible outcomes. On a single roll, what's the probability of rolling a 6? Well, out of 6 outcomes total, only one outcome is considered a success, rolling a 6. If we convert that to a decimal, grab your calculator, punch in 1 divided by 6. You should have gotten 0.1666 repeating, which as a percentage is 16.6 with a bar over that decimal 6%. the chance is pretty weak. In fact, if we look at the probability scale, which happens to be cut into fourths, let's see where a little over 16% would fall in the probability scale. We know our scale stretches from 0 to 1, and it's currently cut into fourths. But the halfway mark would be 3/6, or 3 out of 6, which is equivalent to 1/2. And 1/6 would be approximately here, and 2/6 might be about here. 3/6 is in the middle. 4/6 would be about here. And of course, 5/6, give or take a little bit, would be here. 16.6 repeating percent would fall here on the probability scale. It has a rather weak chance of occurring. But let's think about another single roll. What's the probability of rolling an even number or the number 1? Any one of those results would be a success on a single roll. Well, we know we have 6 possible outcomes total. An even number would be a 2, a 4, a 6. And you can also throw in there a 1 as a success. That would be a 4 out of 6 chance of being a winner on a single roll, which of course reduces down to 2/3. Now grab your calculator and punch in 4 divided by 6 or 2 divided by 3. Doesn't really matter, you'll get the same result. You should get 0.666 repeating. And as a percentage, scoop, scoop, you get 66.6 with a bar over our 6, of course. That's a repeating decimal, percent. You would fall about here on the probability scale. You'd have a bit more chance of getting that to occur than our first roll. Let's keep going. Let's try another. Let's try this. You're a winner if you roll not a 6 on a single roll. Now it's still out of 6, but let's look at our list. Identify all the numbers that are not a 6. 1's not a 6, neither is 2, 3, 4, or 5. That means we have a 5 out of 6 chance of getting that to occur. Grab your calculator and punch in 5 divided by 6 and convert it to a decimal. You should have gotten 0.8333 repeating. And when we move the decimal 2 places, it's 83.3 with a bar over it percent. Now that puts us here at 5/6 on the probability scale. That has a pretty strong chance of occurring, rolling a not 6 on a single roll. How about this one? What's the probability of rolling a 7 on a single roll? Well, as you look at your list over here, not a single 7 on the list. You would have a 0 out of 6 chance, which is a 0 probability, a 0%. That is what we call impossible. That puts us here on the far end of the probability scale. On the other hand, we could come up with an event that's certain. For example, what's the probability of rolling not a 7? Well, if you look at your list, that's not a 7, neither is that or that. All of these outcomes are not 7. We would have a 6 out of 6 chance, or 1, or 100% chance of occurring, which would put us here on the probability scale. Okay, let's do one more, and that will conclude this lesson. Here we go. What's the probability of rolling a 2 or a 3 on a single roll? Keep in mind our list of outcomes. 2 would be considered as a success, and so would 3. That's a 2 out of 6 chance, or 1/3. Punch in 1 divided by 3, or 2 divided by 6. You should get 0.3 repeating. As a decimal, it's 33.3 with a bar over that decimal 3% chance, which puts you here on the probability scale. You have less than an even chance of getting that to occur. This concludes page 2 of your probability packet.